All right, welcome students. Our next section here, as you can see, is going to be entitled stoichiometry. That's how you pronounce that big fancy word. I know it's one of those big words and it looks easy to trip up on, but it is pronounced stoichiometry. And this is going to be one of the big concepts this semester. So it is going to be key that we master this, and we're going to do a lot with practicing on this. And it's connected to we are introducing chemical equations and how to balance them and how those are connected to reactions. This is kind of connected to that as well. It also connects to the earlier section we did on the mole. We're going to be talking a lot about the mole here in this as well. And you'll notice it's entitled the measurement of elements, because that's basically what stoichiometry means, is measuring elements. And I would equate this to basically, we talked about chemical equations being like a recipe. And so this is kind of like, well, you're going to have your family over, and that recipe for chocolate chip cookies, you need more than the normal recipe calls for. Maybe the normal recipe serves 6 people, and you're going to have 12 people at your house, or you're going to have 20 people at your house, and so you need to double or triple or quadruple the recipe. And so that affects, as you go and you make the recipe and you have, let's say, flour or the sugar that you use, you're going to have to adjust the measurements of those. So if you have something like 3/4 of a cup of sugar for one recipe, and now I'm tripling the recipe, I have to figure out, well, okay, what's 3 times that amount? Or if I want to make 2.5 recipes, then okay, what's 2.5? How do I adjust the recipe there? That's a lot of what stoichiometry is about, is if I want to make product X over here, and it takes this and this in a chemical reaction to make product X, how much of those do I need? And what if I want more than just the amount that the chemical equation makes? Or what if I want just a small amount? What if I want a sample batch to test in a lab to see, what are some of the properties of this? Or maybe I want a sample batch to use to test for, something else. Then I need to adjust, again, my recipe for that. So we're going to kind of learn how you do that with chemical equations. It's a similar idea, with obviously some variations, because you're not using cups of sugar or cups of flour. We use slightly different measurements in chemistry rather than cups and tablespoons. Our biggest way of measuring is grams and moles, and so that's what we're going to be doing a lot of, is changing between grams and moles. We're going to start off dealing with moles today, so that's kind of our first change. You see here we have, and we'll get to all of this here in just a second, it's entitled mole-to-mole conversions, and you should have a section in your notes on mole-to-mole conversions. That's all we're going to do today, is just mole-to-mole conversions. And you see you have a chemical equation there. It's already balanced, so we don't need to balance it. So that part is taken care of. And if you look, you have phosphorus, or P4, plus 5O2 yields 2 diphosphorus pentoxide. And so you have your ingredients there, phosphorus and oxygen, and they mix together, and it produces the substance diphosphorus pentoxide. And basically your ratio there is 1 mole of phosphorus plus 5 moles of oxygen plus 2 moles will produce 2 moles of diphosphorus pentoxide. And before, we just kind of dealt with the coefficients just as numbers, but now we're going to kind of translate that. The coefficients basically mean moles. Okay, that's how we treat them, because you're not going to deal really with individual molecules. It's not 5 molecules of oxygen will produce 2 molecules of diphosphorus pentoxide. That's the ratio, but you don't really deal with molecules. We deal with much larger amounts, so we're going to deal with moles. So that's what the coefficients represent, are moles. There. So understand that. That's very important and key for you to understand. Be a good thing for you to write down, that the coefficients in a chemical equation are moles. So that's our starting point. So the question here is this. 2 moles of oxygen will produce how many moles of diphosphorus pentoxide? And you'll notice my starting point, which is 2 moles of oxygen. Remember, your starting point for anything is always what you're given. Okay, my starting point is 2 moles of oxygen. And you notice in the recipe, a normal recipe to produce 2 moles of diphosphorus pentoxide would require 5 moles of oxygen. So that right away that tells me what I'm asking for here is a recipe that's less than the normal recipe. So I need to adjust everything else. If I change the amount of oxygen I have, just like in a chocolate chip cookie recipe, if I change the amount of flour that I used, I would have to adjust everything else. If I cut the amount of flour down by a third, I would have to do that to everything else in order for it to work. And so the same thing here, I'm decreasing the amount of oxygen that I have, the number of moles. So I'm going to have to figure out, well, how many moles of diphosphorus pentoxide would that produce? And it's actually a rather simple setup. It's very similar, and it's related to the conversions that we have done before in this class. And you notice I have part of it set up already for you. You're going to start by writing 2 moles of O2 there, over 1, if you want to put the over 1. That's fine. If you don't want to put that, just start with the 2 moles. And then times, that's what the little asterisk is there, times. And then remember, anytime you're converting, and in this case, we're actually going to convert from moles to moles. Okay. And the reason why we're going to do that, the only way that I can jump from one element or compound to another in a chemical equation or in my recipe is to go from moles to moles. I have to be using the same kind of unit there to do that. I can't go from grams of one unit to grams of another. So let's say I started with grams of oxygen. I could not go to grams of diphosphorus pentoxide. There's no relationship between the two, none at all. Okay, they're 2 completely separate substances, and they're not related, and so I couldn't do that directly. But I can. There is a relationship between the moles, because this chemical equation, the ratio between them never changes, so that allows me to switch between one or the other. And I'll show you how we do that. All right, so the way I would do that basically is I'm going to start with, here, let me get to my pen. And I'm going to start with my 2 moles here of oxygen. And then you'll notice I'm going to come over here, and on the bottom I'm going to go times and then a fraction. And on the bottom of the fraction, I'm going to put moles of O2. Why? So that my units cancel out. And you'll notice this time around I'm writing the substance in. It is key when you're going from moles to moles and you're using stoichiometry to keep track of what units you're in and what compound you're in, because you're actually going to switch from one compound to another. And so you'll notice I put moles of O2 on the bottom so that moles of O2 cancel out. And I want to be, because the question asked me how many moles of diphosphorus pentoxide. So I put moles of diphosphorus pentoxide up here. So you notice that. That's what I'm trying to get into. Then once I have my units, remember we've dealt with this before, always put your units first before you put any numbers or values. It's key to do that. Then I'm going to go and put, well, how many moles of diphosphorus pentoxide I have and how many moles of oxygen do I have. I get those answers from up in the chemical equation. Okay, if you remember earlier, we said that the moles in a chemical equation are your coefficients. So here's one coefficient, here's O2, that's 5, so I'm going to come here where O2 is, and I'm going to write 5. And then I'm going to come over here where diphosphorus pentoxide is, and I have a 2 there, so that's my number of moles, so I'm going to write 2. Okay, so there you go. So you have 2 over 5, that's your ratio between the two. And you always get those numbers from the coefficients in your chemical equation. And then once you have those in, then you just do your math from there. And so I solve, and so this equals, and this would be 4 on top and 5 on bottom, which you don't ever leave it in a fraction form. So that would be, if you were to divvy that out, that would be 0.80 or 0.8, and that would be, again, moles. So we want to make sure and write our units So that would be moles, and that would be your final answer. And specifically, that would be 0.0 of diphosphorus, so P2O5, because you want to make sure that you know which substance that's referring to. So 0.8 moles of P2O5, that would be your final answer and your correct answer in that case. So that's how you do that. It's actually very, very simple to go from moles of one thing to moles of another. Let's go ahead and take a look at another example. And again, if you're following along in your notes, you can be doing these right in your notes. And if you look at this next one, we'll use the same chemical equation here. And the question this time is, if I want to produce 0.25 moles of diphosphorus pentoxide, how many moles of phosphorus will I need? And so you see we set up our what we know originally. So we come over here and we write, so here's what we have originally is 0.25 moles of diphosphorus pentoxide. And we set up then we're going to multiply by a fraction because I'm converting from one substance to another. Anytime I convert, I'm always going to multiply by that fraction. And then what am I going to put in that fraction? Well, the first thing I do is I'm going to write on bottom moles of diphosphorus pentoxide. Why? Because I want to get rid of those units. So those are going to cancel out with each other. And I want to put the units that I want to be in, which in this case, the question is how many moles of phosphorus. So I'm going to go from moles of diphosphorus pentoxide to moles of phosphorus. So that's why I put that up top. And then once I have that, remember, when I'm going from moles to moles, I'm going to look at my ratio in my chemical equation. So I look here, what number is in front of phosphorus, and if it's not written, then it's 1. Okay, so and there's a 1 there. And then I look over here in my chemical equation for diphosphorus pentoxide, and my coefficient is 2. And so I'm going to put a 2 down here. And so in this case, my ratio is 1/2. And then I'm going to go ahead and do my math, and I end up with 0.25 divided by 2. And I will let you do the rest of the math from there. That would be your final answer. And again, it would be whatever that answer is, moles of phosphorus or moles of P4. Always make sure that you write your units. So that's how you convert. That's the beginning step of stoichiometry. How do I move from one unit of, or one element or compound to another compound in terms of moles? That's the first step. What we'll learn a little bit later is, well, what if I don't start in moles? What if I started in grams? So let's say I had 20 grams of phosphorus, and I wanted to go how many moles of oxygen would be needed, or how many grams of oxygen would be needed to partner with that in order to create this reaction. Well, I could figure that out pretty easily, but that would require going from I would need to go from grams of phosphorus to moles of phosphorus first, and then once I'm in moles of phosphorus, I can do the step right here that we just did to go from moles of phosphorus to moles of oxygen or moles of diphosphorus pentoxide. So we're just going to add kind of another step, and then after that we'll add even one more step. So over the next couple days we'll just kind of add a little bit to each of these conversions here. But none of it's going to be super complicated. It's just making sure that you keep track of everything. All right. I will see you later in class.